Lenz's law of practice. Suppose I have a magnet, north end this way, and a loop here, and I decide that I'm going to move the magnet away from the loop. Which way do we get current in the loop? First, B. The magnetic field is coming out of the north pole of the magnet, so B is to the right. Second, the change in B. Is this getting weaker or stronger? The magnet is traveling away, so the magnetic field is going away. It's getting weaker. Because it's getting weaker, it points left. B induced is always opposite delta B. So delta B is this way. Delta B is left, and B induced is this way. Finally, a right-hand rule. If the B induced is this way, it's got to be counterclockwise as seen from the right. If you're looking from the magnet side, it would be clockwise, but seen from the right, it's counterclockwise. You could say down in front, or you could draw a big down arrow and little up arrows to make it clear. Another case, quickly. If we have a wire carrying a steady current, if I have a loop here, and it's just sitting there, I get no induced, because we don't have a change in flux. But now suppose I grab hold of this and give it a velocity this way. The magnetic field is in. From the right-hand rule, magnetic field is in. Is the field getting stronger or weaker? It's getting weaker because we're getting away from the wire, away from its magnetic field. So delta B is in. Out. Delta B is out. The B induced is in. And so finally the current induced, to make a B field going in, it's going to be clockwise. Okay, one last point. In terms of what would be the force on the magnet, for example. Think about energy. If you're inducing a current, you're spending energy. Where's that energy coming from? The kinetic energy of the objects. Which means whatever force is going to act on the magnet or the loop is going to act to slow it down. The magnet is retreating, so the force is going to be to the right. This magnet is going to be attracted to this loop. Likewise, this is pulling away. We have energy, so the net force is going to act to slow this thing down. We're converting kinetic energy into electrical. So the force on this loop is up. I don't have to go through all the right-hand rules to find out. I hope that helps.